Good morning, everyone. This is Jacob Palmer from Palmer Electrical. Thanks for tuning back into the Palmer Electrical YouTube channel. As always, if you like what you see in the video, leave a like, leave a comment and tell me how you think I did, and hit the subscribe button if you feel compelled to do so. Today, we're installing a new 20 amp, 120 volt receptacle circuit in the garage. The panel's on one side of the garage, and the receptacle that I need to install is on the opposite side of the garage. So I'm gonna show you a couple different techniques on how to make that happen. We've got to cut a couple of access holes. We've got a little bit of conduit to run. We're gonna be using EMT metal conduit. Heading to the supply store now to pick up a couple pieces.
Thank you, buddy.
Yeah, man. Let me get 20 feet of 1/2 inch EMT, a box of 1/2 inch EMT couplers.
Set screw or compression?
Set screw, please. 2 RS covers with 1 GFCI and 1 duplex. 2 1/2 inch steel LBs. 1 roll 12-2 Romex. Give me a box of 15 amp tamper resistant GFCIs. 1 1/2 inch by 1 inch nipple. And then let me get 10 1/2 inch plastic bushings, please. And that'll do it, because I got straps.
I got them in plastic. That's what I have them in RF.
Oh, did I say couplers? I'm sorry. These are supposed to be male adapters. My bad. Appreciate your help, sir.
No problem. How's it going?
You too. Oh my goodness. Messy, messy, messy. That's a good looking truck over there. How about that? To the job site. All right, here is our main panel here. Got a 200 amp indoor main panel here. This is an Eaton CH style panel. What we're going to do is we're going to come out vertically from the panel, up, over, and we're going to fish our wire across this joist bay here. The plumber opened this hole up clearly. Looks like he had to make some sort of repair. I took a look, and this joist bay is totally open all the way across to the panel wall there. And then it's also open this way over here to this wall. So we're going to use a couple of these access panels for walls and ceilings. I've got 2 of these. We're going to put one right here directly above the panel, and we're going to put one right here in the ceiling directly above the panel. And what that's going to do is that's going to allow me plenty of access to get proper connectors in the top of the panel here, fish our wire through the top plate of this wall, and then also to make a hole through this joist here. Hopefully there's one there already. And that's going to allow us to fish a wire all the way across to that hole there. We're going to change over to EMT conduit over here. The receptacle is going to go right here next to this fridge. We're going to poke a hole through the ceiling here and fish the wire between here and here. That way, I don't have to make any excessive drywall cutting through the ceiling here. That's going to save time. It's going to save money. It's also going to save mess. First thing I'm going to do is get these work areas cleared out over there by the panel, and then also here above this fridge. Move some of these items out of the way so that we have a walkway, and then we'll get started cutting the holes above the panel. We'll get one of these labels out of the access panel. I fold it in half to get the center line. Just a dot. Mark a horizontal line. There we are. And then we're going to put one on the ceiling right up here. There we are. All right, our access holes are cut. We've got access right down to the top of the panel, right up to the top plate. And then we've already got a hole punched right through engineered joist here. So there should be no problem fishing this down. So that's going to be my next step, is to get a fish rod through this hole here, all the way to that access hole down there. Some of my fish rods are broken. I've got 2 of them just taped up together here. It should still work fine though. Let's go see how close we are in the other hole. I can see it down there just barely. Definitely have some more distance to cover. All right, I made this little hook out of another fish rod and I got a hold of it. Here's our rod. Let's hook up our wire to that end, pull it through. There we go. We got our wire fished across. That's pretty much the hardest part out of the way right there. We need to pull enough slack through this hole here so that we can fish the rest of the way across the ceiling and then also make it through the conduit and down without any splices. Get up here and just tug some more. All right, we can be done with the glow rod. Next step is to get our wire through a new hole that we'll drill in the ceiling here. We can see through this cavity that we're not going to be drilling into anything, which is good. Then we're going to use 1/2-inch EMT conduit to come over. We're going to bend a kick so that the LB goes up into the middle of the ceiling down to a 90, and we'll secure our 1-hole straps to this vertical stud that we can see. And then our outlet is going to go right down here next to the fridge. Let's start bending some pipe. All right, I've got a scrap piece of EMT for this. It's about 5.5 feet long, which I believe will be just enough for what we need. 1/2-inch EMT bends 5 inches to the top of the 90, so we should only need about 9 or 10 inches. So it looks like we should be able to get exactly what I need off of this one scrap. I have extras just in case. After all, I am a residential guy. I really don't bend pipe all that often, but I know how to do it, and I like to use steel conduit in garages and things because stuff kind of gets tossed around in here. Adds a little bit of extra protection. PVC conduit is a lot easier to run and would be equally acceptable for a space like this. But the metal conduit does also add a perceived value to the customer. When they look at it at the end, they see the metal conduit and it looks a little bit nicer and they know it's more sturdy. First, we'll bend our 90. We'll eyeball it. Looks good to me. I'm gonna go ahead and bend the kick to line up with our LB. Kick doesn't need a lot. That's it. There's my 90 and my kick for the LB. Now we're gonna bend our box offset to go into our 4-square box. Just a little bit, and flip it over. There we go. I'll show you what I did. So here's our pipe. Got our box offset. It's going to go right here. Our 1-hole straps are going to secure to this stud. The kick out is to avoid any dead wood right here that could be above this edge of the sheetrock. Box offset, that's right where our box is going to be, next to the fridge. Not too bad for a residential guy, huh? All right, get the rest of my conduit fittings set up here. I've got a 1/2-inch metal LB here. Take one of these 1/2-inch EMT fittings. I always get the kind with the bushing on the inside. And then when you're dealing with LBs, when you take the other screw out, don't put it anywhere other than back into the threaded hole where it came out of. If you lose this thing, it's a big pain. That also goes for panel cover screws when you take those off. I've got a 1-inch nipple that we're going to thread in to the side that's going to go up into the ceiling. And I'm going to protect this metal edge with one of these plastic bushings right here. Of course, this is metal conduit, so it's going to have to be grounded. It's going to be bonded inside the box, just like so. I'm going to get the conduit mocked up approximately where it'll be, and then I'm going to make a made a mark in the ceiling where the hole in the LB is going to go up. Usually that opening is about 1 1/8 inches. We'll mock that up. Feels about right. Next step, fish this wire into that hole we just made. To do that, I'm going to use this scrap of 12-2 that was on the truck, and I'm going to push it up there because this is close enough for me to reach my arm in there and grab it. So I don't need to use fish rods or anything. This one shouldn't be all that hard. Like I said, we'll connect the end of our new wire to this temporary pull wire, get the rest of the way through. All right, we went from here to here to here. We have plenty of wire to make it down to the box. Before we move on, I'm going to put a staple over the wire right here where it's accessible. Now for Romex wire, if we open up our code book to article 334.30, talks about securing and supporting requirements, tells us that it needs to be installed at intervals not exceeding 4.5 feet. Obviously, we've got a lot more than 4.5 feet of cable in the ceiling here. Isn't that a code violation? No, it's not. And the reason it's not is if we go down here to 334.30b, unsupported cables. Non-metallic sheath cable shall be permitted to be unsupported where the cable Section 1 here says, is fished between access points through concealed spaces in finished buildings or structures, and supporting is impracticable. We are in a finished building or structure here, a finished house. It's fished between access points here, and supporting would be impracticable. That would require a lot more damage to the ceiling inside of this garage here. So the code book is nice to us sometimes and allows us to make these fishes here, and it is not a code violation if there's no staples or supports because it's finished. Obviously in a perfect world it would be, but for situations like this, it's just not practical. But since we have access to it right here, nice and easily, I'm gonna go ahead and add a staple since we have the access to. There we go. Next up, let's get the conduit installed. Feed the end of the cable into our LB fitting. Since we're on the topic of securing and supporting, EMT conduit back here in Article 358.30, securing and supporting, needs to be secured at intervals not exceeding 10 feet, and then within 3 feet of each outlet box, junction box, device box, cabinet, conduit body, or other tubing termination. So technically, for this piece of conduit, we only need one strap, technically. If we put one right in the middle, that would satisfy 3 feet from each conduit body or junction box. But obviously, one strap on this conduit here would not be enough. In my opinion, at least. I'm going to do 3 of them. I put one right here, right after this bend. I'm going to put one just a few inches above the box, and then I'm going to put one in the middle. It's going to cost me about 25 cents to do that, and less than a minute of time, and it's going to add to the securement of the box dramatically. We're going to get our cable fed through our conduit here. Nice bend. That's where our box is gonna go. I'm sure some of y'all were getting ready to comment asking me why I'm putting Romex through this conduit in this damp location. We're in a garage, which is considered a damp location. In our code book, code 300.9, raceways wet locations above grade. Where raceways are installed in wet locations above grade, the interior of the raceway shall be considered a wet location. Same thing considered with a damp location. Technically, the inside of that conduit is considered a damp location because we're in a damp location in the garage. If we go back here to 334, NM cable, use is not permitted. It clearly says is not permitted in wet or damp locations. So what gives, Jacob? You're such a hack. Why are you doing that? It's a code violation. How did you even get a license? What do you even do? Hold your comments. North Carolina has a state amendment allowing up to 6 feet of non-metallic cable in a raceway in a wet or damp location. I'll cite that reference on screen now. Like I said before, this conduit was only 5.5 feet, so we are right on the edge of that, but because of North Carolina's state amendment addressing that, I'm in the clear for this location. Leave a comment. What type of state amendments does your state observe? Stop the video, stop the video. I've got a quick correction that needs to be made about everything that I just said. While I was editing this video, I started thinking a little bit closer about what I was talking about and reading those references closer and realized that I've been under a wrong impression pretty much since I started. I ran a couple questions past Dave Varga at ecp480.com. He's a continuing education teacher. I've been to a couple of his classes, really good classes, and Dave, if you're watching, thank you for pointing out my mistake to me. When we have a conduit, I was always taught that if it's either wet or damp on the outside of the conduit, that also applies to the inside of the conduit. That is what 300.9 says. If we come and read 300.9 closely, we can see here that it says wet locations, but it doesn't say anything about damp locations here. I know that it doesn't say damp. I always just kind of thought it was implied. I did a bunch of reading in the book, and I don't find anywhere where it says that damp also applies to the inside of the conduit. Wet and damp locations are distinct from each other in the code book. If you go to Article 100 definitions, I've always been under the impression it was wet and damp that applies on the inside, so I asked Dave, and he pointed out to me that in a dwelling garage, that location is considered a dry location. 334.12 specifically says that NMB cannot be installed in a wet or a damp location. No. It's only allowed to be used in a dry location. So I did some more research after Dave pointed this out to me, and I found online there's some forums and discussions talking about if a dwelling garage is a dry location or if it's damp. if it's a damp location. I always thought it was a damp location, but Dave pointed out that, you know, I guess a lot of inspectors consider it a dry location. The code book is not super specific. It does not specifically outline what specific locations are wet and damp. It seems like it's probably going to be up to the inspector. Most of the people I found online talking about it say that a dwelling garage is a dry location. I could see an argument where if you have equipment that's very close by to the overhead garage door, I could see an argument that that could be considered a damp location. Common sense would tell you to probably treat it as such. So it looks like either with or without the state amendment I was talking about, the installation that I did in this video is good. But what do you think? Is a garage a dry location or a damp location? Leave a comment. With all that out of the way, we can start getting this outlet box together. We got our knockout busted out here. And we've got our male adapter. Get that nice and snug there. Trim this back. And we're gonna put a level on it because we're civilized. It's level. It's solid. Got a ground pigtail. Good. Tighten up this male adapter, nice and snug. Now we're going to have one GFCI receptacle here, and we're going to have one regular receptacle. I've got to use this Decora receptacle. When I went to the supply house, they didn't have any cover plates here that had a GFCI and then a regular duplex, so this will do just fine. We need two number 12 ground pigtails for our two receptacles. Technically speaking, if we ground this box, that would satisfy the grounding requirements for the two receptacle devices because there's continuous metal to metal contact. I don't think it's all that much extra work to go ahead and pull a couple of pigtails just for redundancy. And then these two wires here are our home run wires, and these are going to go to the line side of the GFCI. Connect these jumper wires first onto the load side. Then I'm going to hook up the ground wire and then our line side conductors. My beautiful girlfriend picked out orange tape for me this time around. There we go. The tape isn't strictly necessary, just something I like to do. We'll get everything tucked back into this 4-square. Now, the RS cover. I like to get all these started first and then tighten them down. Even on the RS covers, I like to get my screw heads vertical. Ready to power up on this side. There we are. Let's work on the panel. It looks like some of these holes have some extra space. Should be able to get it fed right down through. Here we are. Just spread some of this insulation back around and we can get one of our access panels installed. Now it's time to get inside the panel. Got a 1/2 inch Romex connector here. Should be able to get from above. Push out one of these other knockouts. See right back there. All right. Got it fully seated in the panel. Now we will feed our home run down through that connector. There it is. Got it pulled all the way down. Now we'll get another staple. Got it. Access panel. Breaker. Ground. Neutral. And our hot conductor. The GFCIs self-test when they're powered on for the first time. We should hear a click after we turn it on. Come over here. Sure enough, GFI's tripped. Reset it. And we got power. Plug this into the other one and test. Good. That's how it's done. All right, panel's closed up. New breaker right here, circuit number 27. Got a label, and I'm also went ahead and labeled this one that got added below the panel. Whoever installed this didn't label it. I labeled it quad because the customer also asked me if I could turn this outlet here into a quad, as well as this outlet here into a quad. So we're just going to expand both of these to 2 gang boxes and add a GFCI protected duplex receptacle. All right, we're all closed up. Everything's put back where we found it. We've got both quad outlets expanded. Our circuit is labeled. That's how it's done, y'all. It's time to invoice and collect payment. Now's a perfect time to tell you just a little bit about my channel sponsor, Jobber. We live in a fast-moving world, y'all. Jobber is here to help your business keep up with the fast-moving world. Me personally, I'm really excited to use their new Tap to Pay feature. You and your employees can use the phone that you already have to accept Tap to Pay in the field. No extra hardware, no awkward delays, no more, oh, look out for an invoice. Collect payment on site and hit the road using convenient payment features that your customers already use, hardware you and your employees already have, all built into the same CRM software that you know and love. Start your free trial today with the top link in the description, 14 days for free as well as a special discount, and get started using Tap to Pay for your business. Learn more at the link. I gotta get going. We are paid up, lickety split, easy as cake, easy as pie, anything, no sweat on my back, all that stuff. Jobber is the ticket. You can come back and thank me later. That's gonna do it for today's installation. I hope everybody enjoyed. Like I said in the beginning of the video, leave a comment. Tell me how you think I did. What would you have done differently? What type of materials do you usually use for that type of work? Or if you're newer, let me know if you have questions about things that you saw in the video that I maybe didn't address. Thanks for tuning in. It is always a pleasure, and I can't wait to see you guys again here on the Palmer Electrical YouTube channel. Take care.